Hey guys, good evening and welcome back again to your Unacademy Read English channel. I hope all of you are doing great, having a good time. So people, if I'm perfectly audible and visible to everyone, let me know quickly in the chats with some fire emojis. Yeah? Let me know quickly in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Good evening people, good evening and welcome back. Good evening and welcome back, welcome back. Let me know once in the chats first, if all of you can hear me properly, if I'm perfectly audible, visible. Yeah? I think, yes, I am perfectly audible, visible. That's great. Amazing. All right, people. So, as you all must be knowing, today we are going to kickstart one more series, that is the top questions from every chapter, which will include questions from NCERT, be it your in-text questions or exercise questions. Apart from that, the NEET PYQs as well as the JEE PYQs, right? So in this particular session, since we are going to start with this particular series from the chapter mole concept. So in this particular session, I'm going to discuss all the different types of questions which are given in your NCERT from the chapter mole concept, whether they are in the in-text or whether they are mentioned in the exercise. Apart from that, I'll be discussing with you the NEET PYQs as well as the JEE PYQs from the chapter mole concept. Okay? My dear students, I want you guys to be ready with your pen and paper, because when I'll be solving the question, at the same time, you will be solving the question too. Okay? I want you guys to be ready with your pen and paper. Anyways, at the end of the session, I'll be sharing with you the session PDF, the handwritten session PDF of this particular session on my Telegram, which is Wassim Bhat Chemistry Official. All of you who are not the part of the Telegram channel yet, you guys can join the Telegram channel, wherein I keep on sharing all the important information like your session PDFs, DPPs, etc. All those things I keep on sharing in that Telegram group, Telegram channel, right? The ones who are not the part of it, just be the part of it. The name of the channel is Wassim Bhat Chemistry Official, right? So at the end of the session, I shall be sharing the handwritten PDF of this particular session on that Telegram itself. Okay? So, are you all ready, people? Sir, when will you take coordination compounds? Coordination compounds is already taken by Sonali ma'am, right? And she has taught it in one amazing way. You guys can check that. Okay? Just go to the playlist of the Game of NEET 2.0. There you'll find all the sessions which have been done, right? So, are you all ready, people? All ready for the session? Let me know quickly in the chats. The session duration is just going to be for 2 hours, right? I'm not going to stretch the session a lot. Don't worry. In 2 hours, we'll cover all the types of the questions which can be asked from the mole concept, right? And you know, most of the times questions are asked directly from your NCERT, right? So in this particular session, we are going to cover the NCERT questions first from the chapter mole concept. All ready? It is just I want you guys to be with me till the end. Session duration is not going to exceed 2 hours. Don't worry about that. Okay? Perfect. Perfect. All right then. So let's get going. Let's get started. And before starting the session, the ones who have not subscribed to the channel yet, I would highly recommend you guys to subscribe to this particular channel, right? So that, and at the same time, do share this particular video with everyone whosoever is preparing at home, not going for the offline classes or the paid batches, right? Do share these sessions with all of them so that they get benefited out of these sessions. Okay? Perfect, guys. So let's get going. Let's get started with the chapter that is your epic mole concept. Yeah? So I'm starting with the first question, people, which is on your screen. The first question, which is from your NCRT in text. This is the NCRT in text question. Look at the question carefully. Just look at it properly. What do you think? Will you be able to solve this question on your own? What do you think? A lot of people already gave the answer, 36 grams. Wow, amazing. Amazing, guys. Amazing. That's what I want. Perfect. All right. So look at the first question, which is from your NCRT in text. The question is, calculate the amount of water produced by the combustion of 16 grams of methane, right? So my dear students, as per this particular question is concerned, we are doing the combustion of methane. We are doing the combustion of methane. Combustion of methane means CH4 plus O2. CH4 plus O2. And combustion of hydrocarbon, you know it, it always leads to the formation of carbon dioxide and water. So in this particular reaction, what all things will be getting over here? As you all must be knowing, when the hydrocarbon undergoes combustion, it leads to the formation of carbon dioxide and water. My dear students, before looking at the question, first of all, what are we supposed to do? We are supposed to balance the reaction. So let's first of all try to balance the reaction first. Okay? Well, all of you who do not know how do we balance such kind of the reactions, let me tell you guys. Let's say you have got the hydrocarbon in this format, CXHY, and you are doing its combustion. It is going to lead to the formation of carbon dioxide and water as well. So first of all, you should know how to balance it. See, how do we exactly balance this sort of a reaction? How many carbon atoms do we have here? X. Take this X, make the stoichiometric coefficient over here. How many hydrogen atoms do you see here? Y. Y, right? So over here, the stoichiometric coefficient is directly going to be Y by 2. And the stoichiometric coefficient of oxygen here is going to be X plus Y divided by 4. This is how you are going to balance any sort of this particular reaction. Okay, number one. Now, I'm going to move into the question. We are supposed to balance the reaction first. So we have got one carbon atom. So stoichiometric coefficient here is 1. We have got 4 hydrogen atoms. 4 divided by 2 comes out to be 2. And this is going to be X plus Y by 4. So 1 plus 4 by 4, that comes out to be 2. Now the reaction is balanced. Now, as per the question, we are going to do the combustion of 16 grams of methane. So my first thing is going to be to convert the given quantity into number of moles. My dear students, first of all, identify what is your given quantity. Look at this particular given quantity. As you can see, we are given with mass of methane. So let's convert the given mass of methane into its moles. So number of moles of methane is equal to given mass of methane in grams divided by. What is the molar mass of methane? Molar mass of methane is going to be 16 grams per mole. So can I say we are starting with 1 mole of methane basically? Can I say we are starting with 1 mole of methane? Absolutely. Right? We are starting with exactly 1 mole of methane. So my dear students, as per this particular question, we are going to do the combustion of 1 mole of methane. As per this particular question, we are going to do the combustion of 16 grams of methane, which means that we are going to do the combustion of 1 mole of methane. Correct? Now look at the balanced chemical equation. Stoichiometric coefficient here is 1. And stoichiometric coefficient here also is 1. From the stoichiometry of the reaction, can I say when 1 mole of methane undergoes combustion, 1 mole carbon dioxide is produced. This is something which I got from the stoichiometry of the reaction. That's all. When 1 mole methane undergoes combustion, 1 mole of carbon dioxide is produced, right? So 1 mole of carbon dioxide means how many grams of carbon dioxide? It means that 44 grams of carbon dioxide. What were we supposed to calculate? Calculate the amount of water. So first of all, this is something which you call as, this is something which is going to be your amount of carbon dioxide produced. This is the amount of carbon dioxide produced. Now let's calculate the amount of water. Okay. Look at the stoichiometry again. Here the coefficient is 1. Here the coefficient is 2. Can I say from the stoichiometry I got to know when 1 mole methane undergoes combustion, I would say 2 moles of water are produced. Right? And 2 moles of water means how many grams of water? It means 36 grams of water. So 36 grams of water will be produced at the end of the reaction. This is something which I was supposed to calculate. This is something which I showed extra over here, right? I believe this is super clear to everyone. All right, people, let me know once in the chats if you can solve this sort of a question on your own. Quickly in the chats. Everybody. Say yes or no in the chats. I want the chats to run continuously. I want the chats to run continuously, guys. Everybody. Yeah? So one simple and basic question and it's done, right? Now you must be thinking, how come I wrote 36 grams of water? My dear students, how many moles of water are formed? See, moles of water produced is equal to 2, right? Moles of water produced is equal to 2. How do you convert moles into mass? How do you convert moles into mass? You just multiply the moles by the molar mass. That's it. You just multiply the moles by the molar mass. So 2 multiplied by 18, the value comes out to be 36 grams over here. Done and dusted. One simple and basic question this was. Perfect. Let's move on to the next question. This is again the NCERT in-text question, guys, and I believe you should be in a position to solve this on your own. How many moles of methane are required to produce 22 grams of carbon dioxide after its combustion? So as per the question, my dear students, as per the question, we are again doing the combustion of methane. And we saw a few minutes back, when methane undergoes combustion, what do we get? We get carbon dioxide, and with carbon dioxide, we get water as well. So first of all, what am I supposed to do? I am supposed to balance the reaction first, right? So if you balance the reaction, this becomes 1, this becomes 2 over here, and this becomes 2. Now it's a balanced chemical equation. Now look at the question carefully. Look at the question carefully. How many moles of methane? How many moles of methane are required to produce 22 grams of carbon dioxide? How many moles of methane are required to produce 22 grams of carbon dioxide? My first step is going to be to convert the given quantity into number of moles. Yeah, that's always our first step. Convert the given quantity into number of moles. So my dear students, let me convert this mass of carbon dioxide into the moles of carbon dioxide, right? How do you convert mass into moles? Given mass divided by molar mass. What is the given mass of carbon dioxide? 22 grams, right? What is the molar mass of carbon dioxide? 44 grams per mole, right? The value comes out to be 0.5, right? So people, as per the question is concerned, as per this particular question is concerned, how many moles of carbon dioxide are supposed to be formed? As per the question, we are supposed to produce 0.5 moles of carbon dioxide. We are supposed to produce 0.5 moles of carbon dioxide. And for the production of 0.5 moles of carbon dioxide, how many moles of methane are required? Just use the stoichiometry and you're done. Just use the stoichiometry. Can I say, in order to produce 1 mole carbon dioxide, 1 mole of methane is required? Absolutely. In order to produce 1 mole carbon dioxide, 1 mole of methane is required. Therefore, as per the question, in order to produce 0.5 moles of carbon dioxide, how many moles of methane will be required? I'll say 0.5 moles of methane would be required. So this is going to be the final answer of the question, which is something I was supposed to calculate. I was supposed to check, in order to produce 22 grams of carbon dioxide. 22 grams of carbon dioxide means 0.5 moles of carbon dioxide. In order to produce 0.5 moles of carbon dioxide, how many moles of methane are required? And my dear students, I got to know that in order to produce 0.5 moles of carbon dioxide, 0.5 moles of CH4 are required. Is this clear to everyone? Is this clear to everyone? Yeah? Let me know quickly in the chats, people. Everybody. Everybody. Yes, Adarsh, we are going to do PYQs as well. We are going to do NCERT in-text, NCERT exercise, as well as PYQs. Okay? Don't worry. All the things will be covered. And chapter-wise, we'll do the things. Chapter-wise, we'll do the things. Okay? All right. I'm moving on to one more question. And my dear students, in your NCERT, this is how you get the solution, right? If you have read the NCERT once, you would be knowing it already. Okay? I'm moving on to one more. Look at this particular question. A solution is prepared by adding 2 grams of a substance A to 18 grams of water. Calculate the mass percentage of solute. So my dear students, it's again a basic question. Let's exactly see what the question says. Imagine that you have got the container. This is the container which you have. In this particular container, we have got 2 grams of some substance A. We have got 2 grams of some substance A, right? And At the same time, we have got 18 grams of water as well in the container. We have got 2 grams of A and 18 grams of water in the container. Okay. Now, first of all, tell me guys one thing. Among these two, among this A and H2O, which one is going to be your solute? You know, solute is always present in lesser amount, right? If you look among these two, which one is present in lesser amount? I'll say A is present in lesser amount. So A over here, I'll be calling as solute, and this B over here, I'll be calling as solvent. A over here, I'll be calling as solute, B, I'll be calling as solvent, and solute plus solvent makes it what? Solute plus solvent makes it a solution. What are we supposed to calculate? We are supposed to calculate mass percentage of solute. We are supposed to calculate mass percentage of solute. And my dear students, mass percentage of solute means? Mass percentage of solute means weight by weight percentage of solute. Mass percentage of solute means weight by weight percentage of solute, which is equal to, it's going to be mass of solute in grams divided by mass of solution in grams multiplied by what? Multiplied by 100. Now, what is the mass of solute in grams? Mass of solute is nothing but 2 grams divided by. What is the mass of solution? Mass of solution is going to be mass of solute plus mass of solvent. So 2 plus 18 comes out to be 20 multiplied by what? Multiplied by 100. The value comes out to be exactly 10. So this is the mass percentage of solute over here in this particular solution, which I was supposed to calculate, right? All of you have already given the answer. That's amazing, wonderful. So let's move on to one more question. Let's move on to one more question. My dear students, look at this particular question. Again, this is the question which is given in your NCERT. This is an NCERT in-text question. Calculate the mass percentage. Calculate the mass percentage of different elements present in sodium sulfate. So, the substance that's given to us is sodium sulfate, Na2SO4. Na2SO4. First of all, I need to calculate mass percentage of different elements in case of Na2SO4. Just tell me one thing. In case of your Na2SO4, which all elements do you see? I can see sodium, I can see sulfur, I can see oxygen. So I've got 3 elements here. One is sodium, one is sulfur, and one is oxygen. I need to calculate their mass percentage. I need to calculate mass percentage of the element in a given compound. I need to calculate mass percentage of each element in this particular compound. Now see, how do you get the mass percentage? See guys, it's pretty much simple. We have discussed this topic in detail in the marathon of the mole concept. I hope you remember that. See guys, mass percentage of sodium. First of all, tell me one thing. Guys. Mass percentage of sodium is going to be equal to, what is the molar mass of sodium? You all must be knowing. Molar mass of sodium is 23 grams multiplied by. In 1 mole of sodium sulfate, how many moles of sodium atoms do you see? I can see 2 moles of sodium atoms, so multiplied it with 2 divided by. What is the molar mass of this whole compound? Understand, I'm calculating the mass percentage of sodium over here, which is equal to molar mass of sodium multiplied by 2 sodium atoms multiplied by 2 divided by molar mass of this entire compound. Molar mass of this entire compound is going to be, see, 2 sodium atoms means 23 into 2, 46. Sulfur is going to be 32. And oxygen, 4 oxygen means 64. So how much this comes out to be? 4 to 6, 6, 6, 12. 4, 1, 5, 3, 8, 8, 6, 8, 6, 14. So 142 grams per mole. So its molar mass is 142. So divided by 142, multiplied it with 100. This is going to give you the mass percentage of sodium in case of this particular compound. As simple as that. Similarly, calculate the mass percentage of sulfur in this compound. How do you do that? What is the molar mass of sulfur? Molar mass of sulfur is 32 multiplied by. How many sulfur atoms do you see here? Only 1 sulfur atom divided by. What is the molar mass of the entire compound? That's 142. Multiply it with 100. You'll be getting the mass percentage of sulfur over here in this particular compound. Similarly, how do you calculate the mass percentage of oxygen? Tell me first of all, what is the molar mass of oxygen? 16 grams multiplied by. How many oxygen atoms do you see here? 4 divided by. What is the molar mass of this entire compound? 142. Multiply it with 100. You'll be getting the mass percentage of oxygen in this compound as well, right? So my dear students, this is how you calculate mass percentage of different elements in any sort of compound. I believe I'm clear with this, okay? Right? So if you want to remember the formula directly to calculate the mass percentage, let me make the formula over here as well. mass percentage of an element, mass percentage of an element in a compound is always equal. It is always equal to molar mass of element multiplied by Z divided by molar mass of compound multiplied by 100. This is the general formula to calculate mass percentage of an element in a compound. And what does this Z represent over here? Z represents number of moles of atoms, number of moles of atoms of an element, number of moles of atoms of an element in 1 mole of compound. In 1 mole of compound, right? Do remember all this stuff, guys. Okay, this is a general formula and we have discussed this in detail in the mole concept marathon itself. Okay, I'm moving on to one more question. And this was the solution of it and you have seen it one-on-one. Let's move on to one more. Now, this is your NCERT exercise question. This is your NCERT exercise question, people. Look at the question and see if you can solve this. It's a simple and basic question, I must say again. Okay, look at the question carefully. Calculate the amount of carbon dioxide that could be produced when 1 mole carbon is burnt in air. So, carbon is burnt in air. Carbon is burnt in air. And what does it form? It is going to form carbon dioxide gas. This is something which you all must be knowing. Carbon is burnt in air. It's going to form carbon dioxide gas. Look at this particular reaction first. Is the reaction balanced? I must say the reaction is balanced. The reaction is balanced already. Okay. Now, as per the question, calculate the amount of carbon dioxide. Calculate the amount of carbon dioxide produced when 1 mole of carbon is burnt. When 1 mole of carbon is burnt. Since the reaction is balanced, stoichiometric coefficient is 1. Here it's 1. So I can say when 1 mole carbon is burnt, as per stoichiometry, when 1 mole carbon is burnt, I would say 1 mole carbon dioxide is produced. 1 mole carbon dioxide is produced. 1 mole carbon dioxide means 44 grams of carbon dioxide will be produced. So this is the answer of the first question. This is the answer of the first question. Look at the second one. Look at the second one. When 1 mole of carbon is burnt in 16 grams of dioxygen. When 1 mole of carbon is burnt in 16 grams of dioxygen. How do you solve this now? Quickly, let me know its answer. Let me know its answer, people. When 1 mole of carbon is burnt in 16 grams of oxygen. Quick. What is going to be the answer of this question? Quickly, people. You should be in a position to solve this on your own. As per this particular question, we are burning 1 mole of carbon in 16 grams of oxygen. Quick. See, guys, understand. Let me first of all write the reaction again. Let me write the reaction again. C plus O2, it gives what? It gives carbon dioxide. The reaction is balanced. So, initially at time t is equal to 0, how many moles of carbon are we given with? As per the question, 1 mole of carbon. How many grams of oxygen do we have? We have got 16 grams of oxygen. 16 grams of oxygen means 16 by 32, 0.5 moles of oxygen. So we have got 0.5 moles of oxygen. Initially, this is going to be 0, right? Now, if you use the concept of limiting reagent, tell me which one is the limiting reagent among the two? How do you identify the limiting reagent? Given moles divided by stoichiometric coefficient. The one that gets the lesser value, that's the limiting reagent. So 1 by 1 is 1, 0.5 by 1 is 0.5. So O2 is my limiting reagent here. So it gets completely consumed. So I'll be left with nothing. Now entire carbon dioxide formation is going to be decided by O2. I can say 1 mole O2 gives 1 mole carbon dioxide. So 0.5 moles of O2 is going to give me 0.5 moles of carbon dioxide. So I got to know 0.5 moles of carbon dioxide are produced, right? And 0.5 moles of carbon dioxide means how many grams of carbon dioxide? It means 22 grams of carbon dioxide, right? It means 22 grams of carbon dioxide here are produced. So the second question is again done and dusted. Look at the third one. 2 moles of carbon are burnt in 16 grams of dioxide. Now again, this is something which I believe you can easily solve. Write the reaction again. C plus O2 gives carbon dioxide. Initially now, how many moles of carbon we are starting with? We are starting with 2 moles of carbon. How many moles of O2 we have? We have 16 grams of O2. That means we have got 0.5 moles of O2. So in the beginning, this is going to be 0, right? Now we use the limiting reagent again. 2 divided by 1 is 2. 0.5 divided by 1 is 0.5. So this is my limiting. it would have got completely consumed. So nothing would be left. Nothing would be left. Now entire carbon dioxide production will be decided by O2. 1 mole of O2 gives 1 mole of carbon dioxide. 0.5 moles will give me 0.5. So I got to know in this particular reaction, 0.5 moles of carbon dioxide are produced, right? But am I supposed to calculate moles of carbon dioxide? No, I'm supposed to calculate the mass of carbon dioxide, right? So my dear students, 0.5 moles of carbon dioxide means 22 grams of carbon dioxide. So again, I would say 22 grams of carbon dioxide would be formed at the end of the reaction. So this is how you're going to solve all three of them, right? Am I clear, people? Am I clear? I believe with this approach, you are going to solve each and every question when asked like this. This was your NCERT exercise question from the chapter mole concept, right? All right, look at this one. Look at this one, guys. This is again your NCERT exercise question only from the chapter mole. Can you give this question a try? Can you give this question a try? Check it out. Calculate the mass of sodium acetate required to make 500 ml of 0.375 molar aqueous solution. Molar mass of sodium acetate is this much. Again, a simple and basic question. My dear students, have a look at as per this particular question. You have got a solution whose molarity is given. Molarity of the solution is given to me as 0.375. Volume of the solution is given to me as 500 ml, right? Even molar mass of solute I'm representing with M2. Molar mass of solute is given to me approximately as 82 grams per mole. What am I supposed to calculate? I'm supposed to calculate the mass of sodium acetate. The mass of solute I'm supposed to calculate, right? I'm supposed to calculate the mass of solute, which I'm representing with W2, right? These are the things which are given to me. Now we use the simple formula. Use the simple formula, guys. Molarity is equal to mass of solute in grams multiplied by 1000 divided by molar mass of solute, and this is going to be the volume of solution in what? Volume of solution in ml, correct? Now molarity of the solution, you know, 0.375. Mass of solute I am supposed to calculate, multiplied by 1000. Molar mass of solute is something that's given to me as 82. Volume of solution is again given to me as 500 ml. So cross multiple and get the value of W2, and whatever value of W2 you get, that is going to be your answer of the question. That's all, right? Isn't it simple, guys? Simple formula. If you remember how to calculate molarity, you are done. You're sorted. Okay? Perfect. Right, people? Perfect. So what is going to be the final answer of the question? After solving, the final answer of the question is going to be 15.38 grams, right? This is the approach which is given to us from the NCERT. And you can remember this particular approach as well, right? Okay. Let's move on to one more. Again, one more NCERT exercise question this is. Look at the question carefully. Calculate the concentration of nitric acid in moles per liter. Calculate the concentration of nitric acid in moles per liter. Moles per liter means molarity. Moles per liter means molarity. So calculate the concentration of nitric acid in moles per liter in a sample which has got the density of 1.41 grams per ml, and mass percentage of nitric acid into it is 69. My dear students, if you remember, I had given you one direct result whenever this sort of a question is to be given, right? If you remember one direct result which I have given you in the marathon itself, you should be able to solve this question in less than 10 to 20 seconds. Why is that? Because if you remember the direct result is molarity of the solution is equal to 10 multiplied by density of solution in grams per ml multiplied by weight percentage of solute divided by what? Divided by molar mass of solute. This is one direct result which I have given you already long back. Yeah. Now people, sir, ये तो NCERT के है. Of course. It's a mixture, right? NCERT questions, PYQ, NEET PYQs as well as JEE PYQs. Everything is included here. Just wait. Now see guys, all the things are given to us. Let's have a look. Calculate the concentration. Concentration means molarity. Molarity I'm supposed to calculate is equal to 10 multiplied by, what is the density of solution? Density of solution is equal to 1.41. What is the weight by weight percentage of solute? Weight by weight percentage means mass percentage. Mass percentage of solute is 69 divided by, what is the molar mass of solute? What is the molar mass of nitric acid? Tell me, what is the molar mass of nitric acid? I believe it is going to be 69 only. When you calculate, its molar mass is going to be how much? How much? Say hydrogen is going to be 1, nitrogen is going to be 14, right? 14 plus 1 is 15, 15 plus 48. 15 plus 48. 63, right? Its molar mass is coming out to be 63. Its molar mass is coming out to be 63. Now, it's just the matter of calculation and you are done. You are sorted. Yeah? Perfect? So, after solving, the final answer of this particular question will come out to be 15.44. 15. This is the approach which is given in NCERT. It is the general approach. It is the general approach, guys. Perfect? And this is the shortcut which you can remember. If you just remember this formula, within 10 to 15 seconds, you should be in a position to solve this sort of a question. Okay? Chalo, I'm moving on to one more. Look at this particular question. Again, this is your NCERT exercise question. Now, look at the question carefully and see how you would be able to solve this question. Quickly, guys. Quickly. Give it a try. Give it a try quickly. What do you think is the answer? I'm waiting for your answers. I am waiting for your answers quickly. Everybody. How would you solve this? How much copper can be obtained from 100 grams of copper sulfate? So, you have got 100 grams of copper sulfate. As per the question, we have got 100 grams of copper sulfate. And from copper sulfate, what exactly we have to obtain? We have to obtain copper from it. My dear students, if I ask you, what is the oxidation state of copper here? You will say it's +2, right? It's +2. What is the oxidation state of copper here? 0. So, I would say the oxidation state of copper has to go from +2 to 0. So, decrease in the oxidation state. Decrease in the oxidation state is something which you call as reduction. And reduction means gain of electrons. So, I would say this copper sulfate would be gaining 2 electrons and then would be getting converted into copper. And at the same time, what you will be getting? You will be getting SO4 dinegative as well. You will be getting SO4 dinegative as well. Now, as per the question, how much copper can be obtained from 100 grams of copper sulfate? First of all, if you look at this particular reaction, it's a balanced chemical equation. It's a balanced one. The reaction is balanced chemical equation. Now, my dear students, here the stoichiometric coefficient is 1. Here also the stoichiometric coefficient is 1. How much copper is obtained from 100 grams of copper sulfate? So first of all, let's try to convert the given quantity into number of moles. So my dear students, let me calculate the number of moles of copper sulfate first, which is going to be equal to given mass of copper sulfate in grams divided by, what is the molar mass of copper sulfate? Copper means 63.5, sulfur is 32, and 4 oxygen means 64. So it's going to be 0.5, 3 to 5, 5, 4, 9, 6, 3, 9, 9, 6, 15. So 159.5. Is the molar mass of copper sulfate. So first thing which I did over here, I converted the given mass of copper sulfate into its moles. So technically we have got these many moles of copper sulfate. Now people, the question is done and dusted. Have a look. Can I say as per stoichiometry of the reaction, from 1 mole copper sulfate, you guys are going to get 1 mole copper. From 1 mole copper sulfate, you guys are going to get 1 mole of copper. But are we given with only 1 mole copper sulfate? No. We are given with these many moles of copper sulfate. So I would say 100 divided by 159.5 moles of copper sulfate. Moles of copper sulfate are going to give us 100 divided by 159.5 moles of copper. But as per the question, was I supposed to calculate moles of copper? I'm supposed to calculate mass of copper. Now, how do you convert the moles of copper into mass of copper? Mass of copper is going to be equal to moles of copper multiplied by the molar mass of copper, which is 63.5, and the answer here is going to be in grams. right? So my dear students, I would say this is going to be the mass of copper which will be produced from 100 grams of copper sulfate. So I believe this sort of a question, again, you should be in a position to solve from now onwards. Okay? I'm moving on to one more question. See guys, this sort of a question I would have showed you many a times. In the marathons itself, right? Calculate the average atomic mass of chlorine using the following data. It's pretty much simple. I believe you should be remembering its answer as well. Yeah? This question we have discussed many a times. My dear students, as per the question, we are given with the element chlorine. And this chlorine over here, it has got two isotopes. One is your Cl35, one is your Cl37. So approximately I'm using 35 and 37, right? And at the same time, the percentage abundances of these isotopes are given to us. This is 75% approximately, and this is 25% approximately. Correct? Right? Now see, this is it. That's it. We are given with the element chlorine. Chlorine has got two isotopes. And whenever element has got isotopes, what do we calculate? We calculate average atomic mass of that element. How do we calculate the average atomic mass? I hope you remember the formula is M1A plus M2B divided by what? Divided by A plus B. If you call this as the value of M1, if you call this as A, if you call this as M2, if you call this as B, you are done. Just put the values over here. M1 is 35, A value is 75, M2 value is 37, B value is 25, divided by A plus B. A plus B will directly come out to be 100. And when you solve this, the value is going to come as 35.5 AMU, which is what I call as average atomic mass of chlorine, which I was supposed to calculate, right? Simple and basic question again this was, and this was also your NCERT exercise question only, okay? Now, one more question which is from your NCERT exercise. Look at the question carefully, guys. In 3 moles of ethane, calculate the following. All right. As per the question, we are given with 3 moles of ethane. What are we supposed to calculate? The first thing, calculate the number of moles of carbon atoms. Number 2, calculate the number of moles of hydrogen atoms. Number 3, calculate the number of molecules of ethane. So 3 things are we supposed to calculate, right? Now see guys, first of all, if you analyze 1 mole of ethane, my dear students, just tell me, in 1 mole of ethane, how many moles of carbon do you see? I can see 2 moles of carbon. And similarly, how many moles of H do you see? I can see 6 moles of H. And similarly, how many moles of H2 do you see? I can see 3 moles of H2. Right? Even this is something which we have discussed in detail in the marathons. You should be in a position to solve this on your own, guys. I analyzed one thing. 1 mole of ethane contains 2 moles of carbon, 6 moles of H, and 3 moles of H2. But as per the question, am I given with only 1 mole of ethane? No. What am I given with? I'm given with 3 moles of ethane. So I would say 3 moles of ethane. 3 moles of ethane will be containing 3 2s are 6 moles of carbon. Similarly, 3 6s are 18 moles of H. 18 moles of H, and 3 3s are 9 moles of H2. 9 moles of H2. What all things I was supposed to calculate? The first question was calculate the moles of carbon atoms. These are the moles of carbon atoms. Calculate the moles of hydrogen atoms. These are the moles of hydrogen, right? Calculate the molecules of ethane. Calculate the molecules of ethane. How many moles of ethane do we have? We have 3 moles of ethane. We have got 3 moles of ethane. How do you convert moles into molecules? So I would say if we have got 3 moles of ethane, that means how many molecules of ethane do we have? So moles multiplied by Avogadro's number. So these many molecules of ethane we have. So all the 3 questions are done and dusted, right? This sort of a question you should be again in a position to solve. Okay. Now, by the way, guys, on Wednesday there is one more session similar to this. That's going to be top-notch questions of chemical bonding, in which I shall be discussing your NCERT exercise, NCERT in text, NEET PYQs as well as JEE PYQs from the chapter chemical bonding. So be prepared for that. Be prepared for that as well. Okay. Look at this question, guys. Again, the question from your NCERT exercise. See, what is the concentration of sugar in moles per liter? Moles per liter means molarity. So basically, we are supposed to calculate molarity. If its 20 grams are dissolved in enough water to make the final volume up to 2 liters. See what kind of question this is. We are just supposed to calculate molarity of the glucose solution. And molarity of the solution is equal to mass of solute in grams multiplied by what? Multiplied by 1000 divided by molar mass of solute multiplied by volume of solution in what? Volume of solution in ml. Now, what is the mass of solute? What is the mass of glucose? Is it given? Yes, 20 grams of glucose we have. Multiplied with what? 1000. What is the molar mass of glucose? 180. What is the volume of solution in ml? Volume of solution is 2 liters. 2 liters means 2000 ml. Right? So, I believe this question is also done. And this is going to give you the molarity of the glucose solution. Nothing else. Yeah? Right, people? Right. Is it clear? All right. Okay, look at this one. It's a good one. Look at this particular question. I believe you would have seen this particular question in your NCERT, right? And you should be again in a position to solve this question on your own. If the density of methanol is this much, what is its volume needed for making 2.5 liters of 0.5 molar solution? Look at the question, guys. Someone is asking, in the last question it was sucrose given. Was it sucrose given? What was given exactly? Okay, we are given with sugar, so sucrose, right? Alright guys, so make some certain changes here. So sucrose means sucrose molar mass will be 342. Okay, sucrose molar mass. I thought it's glucose given. Okay, sucrose molar mass will be 342. Now you can do the calculations and stuff. Okay, chalo, let's move on. This was the question. My dear students, we have to make a solution whose molarity should be 0.25, whose volume should be 2.5 liters. What is molarity basically? Number of moles of solute. Solute here is methanol basically. Solute here is methanol divided by volume of solution in liters. This is something which you all must be knowing, right? So molarity of the solution is given to me as how much? 0.25 is equal to moles of solute divided by, what is the volume of solution in liters? Volume of solution in liters is equal to 2.5. So from here, can I get the moles of solute? Moles of solute means moles of methanol. 2.5 into 0.25, which comes out to be how much? I think 0.625. Is that? So what is this particular term? 0.625. What is this particular term? 0.625. These are basically the moles of, methanol which are required. These are the moles of methanol which are required. Correct? If these are the moles of methanol, can I calculate the mass of methanol required? Mass of methanol required will be equal to moles of methanol multiplied by molar mass of methanol. Can you do the calculation for me and let me know what is the value of this particular term which you'll be getting from here? Quickly, everyone. This is the mass of methanol which is required. But as per the question, am I supposed to calculate mass of methanol or volume of methanol? I'm supposed to calculate volume of methanol. You know, as per the question, density of methanol is equal to, it's going to be mass of methanol in grams divided by volume of methanol in ml. This is in grams, this is in ml, right? So density of methanol is given to me as 0.793 kilograms per liter. 0.793 kilograms per liter, right? Or let's do one thing. Let me take the volume in liters here. Let's take the volume in liters. Right? So density of methanol here is going to be, it was 0.793 kilograms per liter. So it's going to be 793 grams per liter. Now it's going to be 793 grams per liter. I multiplied this term with 1000, right? Is equal to mass of methanol in grams is equal to how much? 0.625 multiplied by 32 divided by what? Divided by volume of methanol, which I'm supposed to calculate. Perfect. So from this particular equation, you can easily calculate volume of methanol required, which is going to be 0.625 multiplied by 32 divided by 790. Right? So this is going to give you the final answer of the question. Right, people? Now just a bit of calculation is needed and we are done. So let me give you the quick context of how did I solve this question. First of all, molarity of the methanol solution was given, volume was given. So I calculated moles of methanol in the solution. So these many moles of methanol are required basically. If I got the moles of methanol, I convert it into the mass. So this is the mass of methanol required. But I'm not supposed to calculate mass of methanol. I'm supposed to calculate volume of methanol. You know, density is equal to mass by volume. Density is given. Mass we calculated. So from here you can calculate volume of the methanol required. And after doing all the calculations, the final answer of this particular question will come out to be how much? It will come out to be 25.2 ml, or it can come out to be 0.0252 liters. That's going to be the final answer of the question after doing the calculation. Okay? I believe this sort of a question you can easily solve. Now, look at this one. Again, one NCERT exercise question. NCERT exercise question. Calculate the number of atoms in each of the following. 52 moles of argon. My dear students, the first question is, we have got 52 moles of argon. Argon is monoatomic. Argon is monoatomic, right? So, number of atoms of argon will be equal to moles multiplied by Avogadro's number. I would say these many atoms of argon we have. This was the first question. Second question. As per the second question, we have got 52 U of helium. In 52 U of helium, how many atoms do we have? My dear students, tell me one thing. What is the mass of one atom of helium? 4U. 4U means the mass of one atom of helium. 4U means the mass of one atom of helium. Therefore, if you use unitary method, 1U is going to be the mass of 1 by 4 atoms of helium. But am I given with 1U or 52U? 52U. So 52U is going to be 1 by 4 multiplied by 52 atoms. 1 by 4 multiplied by 52 means what? It's going to be 13 atoms. So the mass of 13 atoms of helium is going to be what? The mass of 13 atoms of helium is going to be what? Is going to be 52U. Correct? This was the second question. Look at your third question. If you look at the third question, we are given with 52 grams of helium. Right? Now the mass of helium is given in grams. So if we are given with mass of helium, so first thing, calculate the moles of helium. It is going to be mass of helium in grams divided by molar mass of helium. So these many moles of helium we have. Now moles multiplied by Avogadro's number gives me atoms. So number of atoms of helium is going to be equal to 13 multiplied by Avogadro's number. So these many helium atoms we have. My dear students, this sort of a question we have discussed in the mole concept marathon. That's why I keep on telling you all the time, before coming to these sort of question practice sessions, you have to watch the marathon first. So our next marathon is our next question practice session is chemical bonding on Wednesday. But before that, I would highly recommend you guys to watch the chemical bonding marathon, which I have taken on this particular channel, I think few weeks back. Okay, then come to the session so that you can solve the questions at least. That's what I want. Okay, basically these particular sessions I have come up with just to boost up your confidence. If you have not watched the marathon and if you are unable to solve the questions, it is going to demoralize you. That's something which I do not want. Okay, so please and please do watch the marathon first, right? If you have watched it already, you can watch it again at 2x speed so that you can, do the quick revision of the marathon and then come for these sort of sessions. That's how it's going to be effective. All right, moving on to one more. Look at this question, guys. Look at this particular question. Calcium carbonate, this is also the NCERT exercise question only. Calcium carbonate reacts with aqueous HCl to give CaCl2 and carbon dioxide. As per the reaction, what mass of calcium carbonate is required to react completely with, 25 ml of 0.75 molar HCl? See, let me first of all write the reaction again. The reaction is calcium carbonate plus 2 times HCl aqueous. What does it give? It gives your CaCl2 aqueous. And with this, what am I getting? I'm getting carbon dioxide gas. And with this, I'm getting water as well. Okay. Now, my dear students, understand one thing. Understand one thing. We are given with molarity of this HCl aqueous solution. What is the molarity of this HCl aqueous solution? 0.75. We are given with its volume as well. Its volume is 25 ml. Volume of this HCl aqueous solution is 25 ml. Or you can say 25 divided by 1000 liters. Right? So this particular solution which we are given with its molarity, we are given with its volume. And you know, molarity multiplied by volume in liters, that gives me moles. So how many moles of HCl do we have? How many moles of HCl do we have here in this particular solution? Moles of HCl in this particular aqueous solution will be equal to molarity of the solution multiplied by volume of solution in liters. Molarity of the solution is 0.75. Volume of the solution in liters is 25 divided by 1000. Right? So these many moles of HCl we have. These many moles of HCl we have. Correct? These many moles of HCl we have. Now people, as per the question, in order to react with these many moles of HCl, what is the mass of calcium carbonate required? What is the mass of calcium carbonate required? Look at the question carefully. Look at the question carefully. Stoichiometric coefficient here is 2. Here it's 1. Can I say, as per the stoichiometry, 2 moles of HCl reacts with 1 mole calcium carbonate? Yes. 2 moles of HCl reacts with 1 mole of calcium carbonate. Therefore, I can say 1 mole of HCl reacts with 1 by 2 moles of calcium carbonate. Absolutely. 1 mole of HCl reacts with these many moles of calcium carbonate. How many moles of HCl we have? We have got 0.75 multiplied by 25 by 1000. These many moles of HCl we have. So these many moles of HCl will react with 1 by 2 multiplied by 0.75 multiplied by 20 divided by 1000 moles of calcium carbonate. Right? So these are the moles of calcium carbonate which we calculated. These are the moles of calcium carbonate which we calculated. But as per the question, am I supposed to calculate moles of calcium carbonate? No. I'm supposed to calculate mass of calcium carbonate. So I would directly say mass of calcium carbonate. Mass of calcium carbonate will be equal to moles of calcium carbonate. Write it again. 1 by 2 multiplied by 0.75 multiplied by 25 divided by 1000. Right? These are moles multiplied by molar mass of calcium carbonate is 100. Solve this particular term and get the answer in grams. So this is going to give you the mass of calcium carbonate which is required to react with these many moles of HCl over here. I believe this particular question is clear to you. If yes, let me know once in the chats quick. Let me know once in the chats quick. A lot of people are coming up with 9.3, 18.75. So it's a matter of calculation now, and after solving, I believe the final answer is going to be 0.9375. The final answer of this question will be 0.9375. Let me move on to one more. See, this is again your NCERT in-text question. See what kind of question this is. Calculate the molarity of NaOH in the solution prepared by dissolving 4 grams, its 4 grams in enough water to form 250 ml of solution. This is something which you can even solve in your dreams also, right? So molarity of the solution is equal to mass of solute in grams multiplied by 1000 divided by molar mass of solute, and this is volume of solution in ml. Now, what is the mass of solute? Mass of NaOH, how many grams? 4 grams multiplied by 1000. What is the molar mass of NaOH? Molar mass of solute 40. Volume of solution in ml is 250. Right? This is 1. This will be 4. This is 1. This is 10. The value comes out to be 0.4. So molarity of the solution is nothing but 0.4. Right? Again, one simple and basic question this is. All right. This is again one question which is given in your NCERT in-text question this is. Again, you should be in a position to solve this question, guys. See, if you look at its general approach which is given in NCERT, that's a lengthy one. But if you have watched the marathon, the same question we can solve with the help of one direct result. That's all. See, density is given. Molarity of the solution is given. What are we supposed to calculate? Molality of the solution. Do you remember there was one result which I had given you long back between molality and molarity? Molality of the solution is equal to 1000 multiplied by molarity of the solution divided by 1000 multiplied by density of solution in grams per ml minus molarity of the solution multiplied by molar mass of solute. This is one direct result which I have given you already. Yeah. If you look at this particular question now, what am I supposed to calculate? Molality is equal to 1000 multiplied by, what is the molarity of the solution? It's 3. Molarity of the solution is 3 divided by, it's going to be 1000 multiplied by, what is the density of solution? 1.25 minus molarity is 3. Molar mass of solute. What is my solute here? NaCl. Its molar mass is 58.5 grams. Just a matter of calculation. Solve this and get the molality of the solution. Correct? Right, people? This sort of a question you can easily solve. If you just remember this result, you are done. Nothing else you have to do. Otherwise, if you want to follow the NCERT approach, this is the NCERT approach which you'll be following, and it might take you a lot of time for this particular question. But if you just remember this result, you're sorted, you're done. Only calculation is required here, nothing else. Okay? Only calculation is required here, nothing else. All right, people. Now, this is your NEET 2020 PYQ. This is your NEET 2020 PYQ. Which of the following has maximum number of atoms? Quick. NEET 2020 PYQ this is. Which of the following has maximum number of atoms? How do you check that? How do you check that? My dear students, the first option is 1 gram of magnesium. 1 gram of magnesium means how many moles of magnesium? I would say mass of magnesium divided by molar mass. So these many moles of magnesium we have, right? Now, moles multiplied by Avogadro's number. So it comes out to be Na by 24. So in the first option, how many atoms of magnesium we have? We have got Na by 24 atoms in the first option. In the second option, 1 gram of O2. 1 gram of O2. Mass of oxygen is 1 gram. So calculate the moles of O2. Moles of O2 will be equal mass of O2 divided by molar mass of O2. These are the moles. If you got the moles of O2, now how many molecules of O2 do we have? Molecules means moles multiplied by Avogadro's number. Na by 32. So these many molecules of O2 we have. Now in one molecule of O2 there are 2 atoms. Therefore in Na by 32 molecules of O2, how many atoms will be there? It is going to be equal to 2 multiplied by Na by 32. So it simply comes out to be equal to Na by 16. So in the second option, you have got Na by 16 atoms. In the second option, you have got Na by 16 atoms, right? Look at the third one. 1 gram of lithium. Perfect. 1 gram of lithium. So how many moles of lithium we have? 1 divided by its molar mass is 7. So if you got the moles of lithium, lithium is in atomic form. So multiply with Avogadro's number, you get atoms. So how many atoms of lithium do you see here? It's going to be Na by 7. So here you have got Na divided by 7 atoms of lithium. In the last option, 1 gram of silver. 1 gram of silver means how many moles of silver? 1 divided by 108. So these are the moles of silver. Now atoms of silver will be simply multiply with Avogadro's number. Na by 108. So here you have got Na divided by 108 atoms of silver. Now, which one of the following has maximum number of atoms? Check it now. Which one of the following has got maximum number of atoms? Na by 24, Na by 16, Na by 7, Na by 108. So Na by 7 is maximum here, right? So option 3 is the one which will be containing maximum number of atoms. This is not some JE level question. It's a proper NEET standard question. And these sort of questions are frequently asked. Right, people? Perfect. This is a question which is asked in your NEET 2015. Look at the question. A mixture of gases contains H2 and O2. So in the container, you have got 2 gases, H2, and with H2, you have got O2, right? In the ratio of 1:4 by mass. So mass ratio of these two, that means mass of H2 divided by mass of O2. As per question, it's given to us as 1:4, I believe, yeah? So it's equal to 1/4. What are we supposed to calculate? We are supposed to calculate what is the molar ratio of the 2 gases. See, the ratio of their masses is given. We are supposed to calculate the ratio of their moles, right? So we are supposed to get this ratio, NH2 divided by NO2. So number of moles of H2 means mass of H2 divided by molar mass of H2. Number of moles of O2 means mass of O2 divided by molar mass of O2. Okay. And this particular term, guys, WH2 divided by WO2, WH2 by WO2. This particular term is given to me as 1/4 multiplied by molar mass of O2 is 32 grams. Molar mass of H2 is how much? 2 grams. So 2, 1. This is going to be 2, 16. 4, 1, 4, 4. The value comes out to be 4/1. So I would say the molar ratio of H2 and O2 over here comes out to be 4:1. Molar ratio of O2 and the molar ratio of H2 and O2 will come out to be what? 4:1. Correct? Am I clear with this particular question, guys? All right. One more question. NEET 2015. NEET 2015. Look at the question. The number of water molecules is maximum in. Which of the following contains maximum water molecules? Option A, 18 molecules of water. So already molecules are given to me as 18. Second, 1.8 grams of water. That means how many moles of water? Given mass of water in grams divided by molar mass of water. So these many moles of water we have, right? So how many molecules of water we have? Molecules of water will be equal to moles multiplied by Avogadro's number. So these many molecules of water we have in the second option. In the third option, 18 grams of water. 18 grams of water simply means 1 mole of water. 1 mole of water contains Na molecules. So here you have got Na molecules of water. Okay. Here you have got 18 moles of water. 18 moles means 18 multiplied by Avogadro's number. So here you have got 18 into Na molecules of water. So where do you see maximum water molecules? I can see maximum water molecules in option 4. Right? Simple and basic question, guys. All right. The question which is asked in NEET 2014. Look at this question. Simple and basic question this is. I believe you should be in a position to solve this one on your own. On your own, you should be able to solve this question, guys. On your own, you should be able to solve this sort of a question. The H2 and Cl2 is mixed, right? So you have got H2 gas and it's reacting with Cl2 gas, and you know it already, it's going to lead to the formation of HCl gas, right? Now guys, tell me one thing. Tell me one thing. 22.4 liters of H2 means 1 mole of H2. 11.2 liters of Cl2 means 0.5 moles of Cl2. In the beginning, this is going to be 0, right? Now use the concept of limiting reagent. You are done. When you use the limiting reagent concept, which one is limiting? 1 by 1 is 1. 0.5 by 1 is 0.5. This is getting the lesser value, so this is limiting. If this is limiting, it's going to decide everything. Now see, 1 mole Cl2 forms 2 mole HCl. So 0.5 mole Cl2 forms 2 into 0.5. 2 into 5.5 means 1 mole of HCl gets formed. 1 mole of HCl gets formed at the end of the reaction, right? So it has to be option 1, which has to be correct. Right, people? Right? It's done and dusted. Let's move on to next. This is the question which has been asked in the year 2010. What do you think? The number of atoms in 0.1 moles of triatomic gas. Let's say you have got a triatomic gas in this form. This is your triatomic gas, right? The number of atoms in 0.1 moles of triatomic gas. First of all, as per the question, how many moles of this triatomic gas we have? 0.1. So how many molecules of triatomic gas we have? How many molecules of A3 we have? Moles multiplied by Avogadro's number. These many molecules of A3 we have, right? Now, one molecule of A3 contains how many atoms? One molecule of A3 contains 3 atoms. Contains 3 atoms. Therefore, 0.1 Na molecules of A3 will be containing 3 multiplied by 0.1 Na atoms. So the value comes out to be 0.3 Na atoms, right? So I must say, in your 0.1 moles of triatomic gas, there will be 0.3 Na atoms, right? Is it clear, guys? Is it clear? And you can put the value of Na over here as 6.02 to 10 raised power 23, right? And get the question done. You all are right? Its final answer is going to be this. Okay. Look at this one. Look at this one. I believe you should be able to solve this one on your own now. It's a similar sort of question. You can see these sort of questions are frequently asked, guys. This question has been asked in your AIPMT 2011. Which of the following has maximum number of molecules? Maximum number of molecules. 44 grams of carbon dioxide means 1 mole carbon dioxide. And 1 mole carbon dioxide contains how many molecules? Na molecules. 1 mole carbon dioxide contains Na molecules. 48 grams of O3 means again 1 mole of O3. It means 1 mole of O3. 1 mole of O3 contains Na molecules of O3. Na molecules of O3. 8 grams of H2 means 4 moles of H2. Right? 8 grams. Given mass by its molar mass. So 8 by 2 comes out to be 4. 4 moles of H2 means how many molecules? 4 Na molecules of H2 here. 64 grams of SO2 means how many? Molar mass of SO2 is also 64. So 64 grams of SO2 means 1 mole of SO2. And 1 mole of SO2 contains how many molecules? It contains Na molecules. It contains Na molecules. What are we supposed to calculate? Which of the following has maximum number of molecules? Maximum number of molecules, as I can see, is option number C. Option C is the one which is correct. Right? Again, one simple and basic question, guys, this is. And you should be in a position to solve this sort of a question on your own. Okay? All right. You would have seen this sort of a question as well in your modules, I believe, whatever you're solving. The weight of one molecule of compound C60H122. C60, my God, H122. This is your compound, right? What is the mass of one molecule of it in grams? First of all, let's calculate its molecular mass. Its molecular mass will be equal to carbon, its atomic mass is 12, multiplied by 60, plus hydrogen is 1, multiplied by 122. So this is going to be 720 plus 122. The value comes out to be 842 U. This is the molecular mass of the compound, 842 U. But I do not need the answer in U, I need the answer in grams. My dear students, you must be knowing about one thing. 1 AMU or 1 U can be written as 1 by Na grams. It can be written as 1 by Na grams, right? So 842 U can be written as 842 multiplied by 1 divided by Na grams, right? And so this is going to be 842 multiplied by 1 divided by Na is 6.022 into 10 raised power 23. Solve it, get the answer in grams. This is the final answer, right? Right, people? So when you solve this, this is going to be the answer which you'll be getting at the end. All right. One more question which has been asked in the year 1990. See, you should be again in a position to solve this one. And I would have showed you this question in the marathon itself, all these types of the questions. See, guys, as per the question is concerned, we have got the element boron. Boron has two isotopes, two stable isotopes. One is B10, one is B11. B10, B11. Their percentage abundance is given to us. The percentage abundance of B10 is 19 and percentage abundance of B11 is 81, right? What are we supposed to calculate? We are supposed to calculate average atomic mass of boron, which has to be nothing but M1A plus M2B divided by what? Divided by A plus B. This is your M1. This is your M2. This is the value of A. This is the value of B. Now put the values, get the answer. That's it. M1 is 10. A value is 19. M2 value is 11. B value is 81. A plus B is nothing but 100. When you solve this, the answer is going to be 10.81 AMU. This is the average atomic mass of boron which you were supposed to calculate. So option 1 has to be the correct answer of this question as well. Right? Clear, guys? Is this clear? Is this clear to everyone? Tell me quickly in the chats. Everybody. Perfect. All right, let's move on to one more. This question, this has been asked in your JEE 2020. Look at the question. Look at the question, guys. Look at the question. Solve it quickly. Rusha, I cannot get harder questions. Well, these are your questions which are given your NCRT, in-text, exercise, and these are your NEET PYQs, right? These are your NEET PYQs. Sir, I am from PW. That's great. Welcome to Unacademy. Solve this question, guys. What do you think is going to be the answer of this particular question? Quickly. The question is pretty much simple. The average molar mass of chlorine is 35.5 grams per mole. The ratio of Cl35 to Cl37 in naturally occurring chlorine is equal to. See, the question is pretty much simple. Again, you should be able to solve this question on your own because we have discussed all of this in detail in the marathons, right? So chlorine, it is existing in two isotopic forms. One is your Cl35, one is your Cl37, right? One is your Cl37. Perfect. I'm going to use our old general approach. If you remember this sort of a question few minutes back, we only solved, right? If you remember this sort of a question few minutes back, only we solved. Well, the average atomic mass of chlorine is going to be what? 35.5 AMU. Average atomic mass of chlorine. Let the percentage abundance of the first isotope be A. Therefore, or let me write it like this. Let the percentage abundance of Cl35 is going to be X. So therefore, this is going to be 100 minus X, right? This is the value of your M1. This is the value of your M2. This is the value of your A. This is the value of your B. So from this particular thing, MAV can be written as M1A plus M2B divided by A plus B is 100. This value is 35.5. Now M1 is 35, A is X, M2 is 37, B is 100 minus X, divided by what? Divided by 100, and this value is nothing but 35.5. And after solving the equation, X value will come out to be 75%. X value will come out to be 75%. Therefore, this is going to be 25%, right? This is going to be 25%. So the ratio is going to be, this is going to be 1 is to 3. So 3 is to 1 is going to be the answer of this particular question, which you should be remembering. You should be remembering now. Yeah. That those questions appear in NEET exam. Of course, this question has appeared in JEE 2020 and it's a proper NEET standard question. Yeah. It's a proper NEET standard question. Of course, this is going to be your level of your examination. See, this is again your NEET question which has been asked in year 1994 from the chapter mole concept. Yeah. Can you solve this? It's again easy. And this question I have solved in the marathon itself. These sort of questions. The question is, if Na is the Avogadro's number, the number of valence electrons in 4.2 grams of nitride ion. So first of all, tell me how many moles of nitride ion we have. Mass of nitride, how many? What is it? 4.2 divided by molar mass of nitrogen is going to be 14. So the value after solving comes out to be how much? 0.3. So basically we have got 0.3 moles of N tri-negative. So how many ions of N tri-negative we have? How many ions of N tri-negative we have? Moles multiplied by Avogadro's number. So these many ions of N tri-negative we have. Now, if you look at one N tri-negative ion, whose atomic number is 7, so how many electrons are there in total? In total, there should be 7 plus 3. In total, there should be 10 electrons. Out of 10 electrons, 2 will be there in the first shell and 8 will be there in the second shell, which I'll be calling as valence electrons. So can I say, in case of your one N tri-negative ion, there are total 8 valence electrons? Absolutely. In case of one N tri-negative ion, there are 8 valence electrons. How many N tri-negatives do we have? 0.3 Na. So in case of 0.3 Na, N tri-negative ions, how many valence electrons do we have? 8 multiplied by 0.3 Na. The value comes out to be 2.4 Na valence electrons. So there will be 2.4 Na valence electrons present in 4.2 grams of N tri-negative, which is something I was supposed to calculate. Even this sort of a question you should be able to solve on your own. Am I clear? Am I clear, people? Am I clear? All right. Moving on to one more. See guys, in 1990, what kind of question was asked? You should be able to, you should not be using pen and paper for this question at least. The number of oxygen atoms. The number of oxygen atoms in 4.4 grams of carbon dioxide. So first of all, how many moles of carbon dioxide do we have? Mass of carbon dioxide divided by molar mass of carbon dioxide. So these many moles of carbon dioxide we have. So how many molecules of carbon dioxide we have? How many molecules of carbon dioxide? 0.1 multiplied by Avogadro's number. So these many molecules of carbon dioxide we have. We know in one molecule carbon dioxide, In one molecule carbon dioxide, how many oxygen atoms are there? There are 2 oxygen atoms. If one molecule of carbon dioxide contains 2 oxygen atoms, therefore 0.1 Na molecules of carbon dioxide will contain 2 multiplied by 0.1 Na. That means 0.2 Na oxygen atoms in total. Right? So these are the total number of oxygen atoms which will be present in 4.4 grams of carbon dioxide. Now after this, you can just put the value of Na here, 6.02 to into 10 raised power 23, and eventually you'll be getting the answer. Yeah? I believe this sort of a question, again, you can easily solve from now on. Okay, one more question, which is the asked question. Look at it carefully. The question is the number of gram molecules. The number of gram molecules. Gram molecules means moles. Gram molecules means moles. Moles of what? Since I'm mentioning gram molecules, so oxygen here I'll be taking in which form? O2 form. So we have to calculate the moles of O2 present in 6.02 into 10 raised power 24 carbon monoxide molecules. As per the question, how many moles of carbon monoxide we have? This divided by Avogadro's number. This divided by Avogadro's number comes out to be 10. So basically, we have got 10 moles of carbon monoxide. And I'm supposed to check in 10 moles of carbon monoxide. In 10 moles of carbon monoxide, how many moles of O2 are there? How many moles of O2 are there? First of all, tell me one thing. In 1 mole carbon monoxide, how many moles of O2 are there? Can I say in 1 mole carbon monoxide, there are 0.5 moles of O2? There is basically 1 mole O. 1 mole O means 0.5 moles of O2. Therefore, I can say if 1 mole carbon monoxide contains 0.5 moles of O2, therefore 10 moles of carbon monoxide will be containing 0.5 multiplied by 10. The value comes out to be 5 moles of O2. Or you can write 5 gram molecules of oxygen. 5 gram molecules of oxygen. Be careful with the terminologies, guys. I know a lot of students would have mentioned 10 as answer, but the actual answer is 5. Okay, be careful with the terminologies. Be careful with all these small things which can mess up in the examination hall. Okay, perfect. Okay, this question, no need to use pen and paper. Tell me its answer directly. 1996, 1 year after which I was born. Tell me its answer quickly, guys. Avogadro's number of oxygen atoms. Avogadro's number of oxygen atoms. That means Na oxygen atoms. That means you have got Na oxygen atoms. What does that mean? That means you have got 1 mole of oxygen. 1 mole of oxygen has got the mass of how much? 16 grams. Molar mass, right? Perfect. Perfect, guys. Oh, wow. Hey, best friend. Nice. When did that happen? When did that happen? Absolutely, guys. So it's option 4, which is the correct answer of this question. Perfect. Let's move on to one more. Let's move on to one more. Tell me its answer. This sort of a question we solved a few minutes back also. And this is the asked question also. In 2014, the question has been asked. In 2014, the question has been asked. Solve it. What do you think? What do you think? Structure of atom marathon I'll be posting in the recorded format next week. Okay? I'm still recording that chapter. I'll be posted in the recorded format. Quickly, guys, the number of atoms present in 52 grams of helium. 52 grams of helium means how many moles of helium? Mass of helium divided by molar mass of helium. So we have got 13 moles of helium. 13 moles of helium means how many atoms of helium? So moles multiplied by Avogadro's number. So these many atoms of helium, right? So 13 multiplied by 6.022 into 10 raised power 23 atoms. So this is going to be 13 into 6, almost 78. 78 into 10 raised power 23 atoms. Is this any of the options? It can be written as 7.8 into 10 raised power 24 atoms. So it's going to be option C. Yeah? Done. Done, guys. Let's move on to one more. Okay, this is the question which has been asked in two examinations, JEE Mains 2014 and 1979. I think this was not asked in 2014, this was asked in 2013. No, 2014, yeah. Right, in 2014 this question was asked, because in 2014 I wrote JEE Mains. And I remember its answer. This was the question asked when I wrote JEE Mains in 2014, and its answer was 7:32. And I did not solve this question in the examination hall also, because I remembered its answer already. I had solved this question before. Yeah? Simple basic question this is. So the ratio of the masses of oxygen and nitrogen. Mass of O2 divided by mass of O2. Sorry, mass of O2 divided by mass of N2. This is given to me as 1:4. What are we supposed to calculate? The ratio of their molecules. The ratio of their molecules. You know, ratio of moles is going to give you the ratio of the molecules, right? So whatever is the ratio of the moles, same is going to be the ratio of the molecules. So I just need to calculate the ratio of the moles. I just need to calculate the ratio of the moles. Ratio of the moles is equal. Moles of O2 means mass of O2 divided by molar mass of O2. Similarly, moles of N2 means mass of N2 divided by molar mass of N2. Now, as per the question, this particular term is given. It is given to me as 1/4. Molar mass of N2 is nothing but 28. Molar mass of O2 is 32. So 4147. The answer is going to be 7:32. So the ratio of the moles is going to be 7:32. And whatever is it going to be the ratio of the moles, same is going to be the ratio of the molecules. So the ratio of the molecules is also going to be 7:32. Right, people? Done and dusted. All right. Look at this question. The question has been asked in the year 2000. Can you solve this easily? The total number of electrons in one molecule of carbon dioxide. One molecule of carbon dioxide. CO2. 6, 12. 8, 16. 8, 16. So in one molecule of carbon dioxide, how many electrons do you see? There are 6 electrons in carbon, 8 electrons in this oxygen, 8 electrons in this oxygen. So the value comes out to be 22. So in one molecule of carbon dioxide, there is just 22 electrons. Yeah? Right, people? Done and dusted again. All right. This question has been asked in the year 2000. This question has been asked in the year 2000, and we have solved this question in marathon itself. We have solved this question in the marathon itself, and I think its answer was 40-30, as far as I remember. Right, people? Someone is saying 219 slides. Actually, I mistakenly told you in the telegram yesterday these are 219, but these are not actually 219. There were some questions repeated. These are 100 something slides. There were some questions repeated in the slides, so it was 219 in total, but actually it's not 219, it's 100 something slides. Okay, so don't worry. We are at this question. What is the answer of this question? See guys, let's try to solve this question again so that you can remember its approach again if you have forgotten. Suppose the element X and Y combines to form two compounds. So we have got two compounds. One is your XY2 Another one is your X3Y2. Another one is X3Y2. These are the two compounds which we have. As per the question, 0.1 mole XY2 has got the mass of 10 grams. Similarly, 0.05 moles of X3Y2 has got the mass of 9 grams. This is something which we are given with. Now tell me one thing. My dear students, if 0.1 mole XY2 has got the mass of 10 grams, therefore I can say 1 mole XY2 has got the mass of 10 divided by 0.1. The value comes out to be 100 grams, right? So I would say the mass of 1 mole of XY2, the mass of 1 mole of XY2 is equal to 100 grams. And mass of 1 mole of a substance is something which you call as molar mass. So I would say molar mass of XY2 is 100 grams. And if the molar mass of XY2 is 100 grams, so molecular mass of XY2 will be equal to 100 AMU, or you can say 100 U. This is the molecular mass. This is the molecular mass of XY2. Now similarly, if 0.05 moles of X3Y2 weighs 9 grams, I can say 1 mole X3Y2 weighs how many grams? 9 divided by 0.05, the value comes out to be 180 grams. So I would say, people, I would say if you look carefully, this 180 grams, this is the mass of 1 mole X3Y2. 180 grams, this is the mass of 1 mole X3Y2. And mass of 1 mole of substance is what you call as molar mass. So this is something which you will be calling as molar mass of X3Y2. And if 180 grams is the molar mass of X3Y2, so its molecular mass will be 180 U. 180 U. So I got to know two things. Molecular mass of XY2, molecular mass of X3Y2. And you must be knowing about one thing. Molecular mass is nothing but sum of atomic masses. Let the atomic mass of X be A. Let the atomic mass of Y be B. So equation here comes out to be A plus 2B. A plus 2B is equal to 100. And from here, I can say 3A plus 2B is equal to 180. 3A plus 2B is equal to 180. So subtracting both the equations, when you subtract them, 2B to be cancelled, 2A minus A, this comes out to be 2A is equal to 80. So from here, A comes out to be equal to 40 AMU. A is equal to 40 AMU. What was A? A was basically the atomic weight of X. A was the atomic weight of X. Now, put the value of A in one of the equations and you'll be getting the value of B over here, and B will come out to be 30 AMU, right? Which is basically the atomic weight of Y. So 40 and 30 is going to be the correct answer of this particular question as well. Right, people? Perfect. Amazing. All right, this is one more question which has been asked in the year 2000. The question is equal masses of H2, O2 and methane. Equal masses of H2, O2 and CH4 have been taken in a container of volume V at temperature 27 degrees centigrade. That means these three gases, they are present under identical conditions. The ratio of the volume of the gases. We are supposed to get the ratio of the volume of the gases. So technically, we need to calculate ratio of the moles of the gases, and whatever is going to be the ratio of the moles of the gases, same is going to be the ratio of the volume of the gases. So what do I need actually? I need the ratio of their moles. I need ratio of their moles. Now, as per question, equal masses of all gases. Let's say mass of this gas is X grams. Let's say mass of this gram is X. Mass of this gas is X, right? So we are given with the equal mass of three gases. So I want to convert them into moles. Mass divided by molar mass. Mass divided by molar mass. Mass divided by molar mass. X cancels out. So the ratio is going to be 1:2. 1 by 2. 1 by 16. Sorry, 1 by 32. And here it's going to be 1 by 16. Now do one thing. Take the LCM of the denominators. What is going to be the LCM of 2, 32 and 16? LCM of 2, 32 and 16 is going to be 32. At least one multiple. So multiply that 32 throughout. Multiply that 32 throughout. So it's going to be 16 is to 1 is to 2. So this is basically the ratio of the moles of the gases. This is the ratio of the moles of the gases. And whatever is going to be the ratio of the moles of the gases, is going to be the ratio of their volumes. Okay. So remember this particular question as well. These sort of questions again are asked in your examination. Okay. All right. One question asked in the year 2019. One question asked in the year 2019. The number of moles of hydrogen required to produce 20 moles of ammonia. See guys, through Haber's process. Haber's process means when N2 reacts with H2, it leads the formation of 2 times NH3. It leads the formation of 2 times NH3. As per the question, how many moles of ammonia are getting formed? As per the question, 20 moles of ammonia are forming. In order to form 20 moles of ammonia, how many moles of H2 are required? How many moles of H2 are required? Use the stoichiometry. If you look at stoichiometry, can I say stoichiometry is telling you 2 moles of NH3. In order to make 2 moles of NH3, 3 moles of H2 are consumed. 3 moles of H2 are used. So I can say, in order to make 1 mole of NH3, 3 by 2 moles of H2 are used. But as per the question, do I have to make 1 mole of NH3? No, I have to make 20 moles of NH3. So can I say, in order to make 20 moles of NH3, how many moles of H2 are required? Multiplied by 20. The value comes out to be 30 moles of H2. So 30 moles of H2 are required to produce what? To produce 20 moles of NH3. So it has to be option C, which is going to be the final answer of the question. Right, people? Right. This question has been asked in your AIMS 2019. AIMS 2019. In a chemical reaction, A plus B gives AB. In a chemical reaction, A plus B gives AB. In which of the following B is acting as the limiting reagent? In which of the following B is acting as the limiting reagent? Okay. In which of the following B is acting as a limiting reagent? Stoichiometric coefficient here is 1, here it's 1. Stoichiometry is same, right? In which of the following B is acting as the limiting reagent? Guys, it's simple. It has to be option C. It has to be option C. Why is that? Why is that? See, initially, how many moles of A do we have? If you look at option C, how many moles of A we have? 50 divided by Avogadro's number. How many moles of B we have? 30 divided by Avogadro's number. So these are the moles of AB initially. Now, which one is limiting? Moles divided by stoichiometric coefficient. Moles divided by stoichiometric coefficient. Which one is getting the lesser value? B is getting the lesser value. The one that gets the lesser value is the limiting reagent. So, if A is equal to 50, B is equal to 20, I would say B is going to be your limiting reagent then, right? So, it has to be option C. Yeah? Done? I believe this sort of a question can be easily solved. This is the question which has been asked in year 2008 from the mole concept. Quick. What volume of oxygen gas measured at 0 degree and 1 atm? 0 degree, 1 atm means your STP condition is needed to burn completely 1 liter of propane gas. So you have got propane, you are doing its combustion. When propane undergoes combustion, what do we get? We get carbon dioxide and water. When propane undergoes combustion, we get carbon dioxide and water. Now you need not to solve this question because the question is already solved. See, as per stoichiometry is telling you that for the combustion of 1 mole of propane, 5 moles of oxygen are required. For the combustion of 1 mole of propane, 5 moles of oxygen are required. Or I can say for the combustion of 1 liter of propane, 5 liter of O2 are required. That's something which you are supposed to check. For the combustion of 1 liter of propane, how many liters? 5 liters of O2 are required. Done? Vinayak is saying, Sir, Hindi bolo please. Bol diya. Hindi. चैनल का नाम एक बार देख ले यार. Sir, a JEE main student can watch your one-shot videos? Absolutely, yes. Yes. Recommended for JEE students as well. Perfect. Let's move on now. Let's move on, guys. Let's move on. Look at this question. The question has been asked in the year 2000. The question has been asked in the year 2000. Assuming fully decomposed, the volume of carbon dioxide released at STP on heating 9.85 grams of BaCO3. So this is something which you need to remember. When BaCO3 undergoes decomposition, it gets converted into what? Barium oxide. And with that, you get carbon dioxide. What do we need to calculate? As per the question is concerned, we are going to heat up 9.85 grams of barium carbonate. And when we heat up 9.85 grams of barium carbonate, what volume of carbon dioxide is produced? That's the question. First of all, how many moles of barium carbonate we have? Mass of barium carbonate divided by molar mass of barium carbonate will be approximately 197. Right? So these many moles of barium carbonate we have. 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 Who are these nonsense people coming into the chats now? Who is this Teenu official? Girls, are you single? No, I'm single. Tell me what. What do you have to do? Nonsense. You should have been in front of me. Wow. I wish you should have been in front of me. I wish. Yeah, I wish. All right, so in this particular question, people, how many moles of barium carbonate are we given with? These are the moles of barium carbonate we are given with. Now, if you look at the stoichiometry is telling you that 1 mole barium carbonate, when it undergoes heating, 1 mole of carbon dioxide is produced, right? So simply you can say, when 1 mole barium carbonate is decomposed, 1 mole carbon dioxide gas is produced. Therefore, when 9.85 divided by 197 moles of barium carbonate undergoes heating, so how many moles of carbon dioxide will be produced? I would say these many moles of carbon dioxide are produced, right? But as per the question, am I supposed to calculate moles of carbon dioxide produced? No. I am supposed to calculate volume of carbon dioxide produced at STP, right? Now, how do you convert these moles into volume? I would say volume of carbon dioxide produced will be equal to 9.85 divided by 197 multiplied by what? 22.4. This is going to be your volume of carbon dioxide produced at STP. Yeah? Done, people? Done? This is how you can tackle this survey question as well. One more question asked in the year 1998. My dear students, as per this question, you are given with a reaction. Reaction is 4 times NH3 plus 5 times O2 gives 4 times NO plus 6 times H2O. Now, as per the question is concerned, you are starting with 1 mole of ammonia and 1 mole of O2. We are starting with these. Now, we have to check what will happen. First of all, guys, first thing. We are given with the moles of reactants. Now tell me which one is the limiting reagent. Divide the given moles by the respective stoichiometric coefficients. 1 by 4, 1 by 5. 1 by 4, 1 by 5. Which one gets the lesser value? O2 gets the lesser value. So that means O2 is the limiting reagent. O2 is the limiting reagent. It would be completely consumed. O2 is the limiting reagent, completely consumed. So I think you are done. Option C. Since O2 is the limiting reagent, so all of the O2 would have got consumed. Nothing will be left. Yeah? Perfect? All right. All right, guys. One more. Look at this particular question. We are given with a reaction, and the reaction is given in this format. 2 times benzene plus 15 times O2 gives 12 times carbon dioxide plus 6 times water. This is my reaction. How many liters of O2? How many liters of O2 are needed for the complete combustion of 39 grams of benzene? So, if we are given with 39 grams of benzene, that means how many moles of benzene are we given with? Mass of benzene, divided by molar mass of benzene. The value is 0.5. So we have got 0.5 moles of benzene. We have got 0.5 moles of benzene. So basically we are supposed to check in order to react with 0.5 moles of benzene, what volume of oxygen is required. Now see guys, have a look. Stoichiometry is telling you that 2 moles of benzene requires 15 moles of O2. Therefore, 1 mole benzene requires 15 divided by 2 moles of O2. Therefore, 0.5 moles of benzene requires. This is 15 divided by 2, sorry. Yeah, 15 by 2. So 0.5 moles of benzene will require 15 divided by 2 multiplied by 0.5 moles of O2. Which comes out to be, this is 1 by 2, so 15 by 4. So 15 divided by 4 moles of O2 are required. But as per the question, we are not supposed to calculate moles of O2. We are supposed to calculate volume of O2, right? How do you convert moles into volume now? So volume of O2 required will be equal moles of O2 multiplied by what? 22.4. Solve this, get the answer in liters. That's it. That's it, people. Right? So the final answer of this particular question is going to be option D. All right. This is one more question. This has been asked in your JEE mains long back. Long back this has been asked. So one thing you need to remember here. 2.76 grams of silver carbonate. Silver carbonate is Ag2CO3. When Ag2CO3 is strongly heated, guys, the term is strongly heated. Remember this particular reaction. When Ag2CO3 is strongly heated, it gets converted into 2 times Ag solid. With that, you get carbon dioxide gas and you get O2 gas as well. So this is the reaction. This is the reaction. The question is, when 2.76 grams of silver carbonate is strongly heated, what is the weight of residue left? When this Ag2CO3 is strongly heated, what weight of residue is left? So when it is heated, it gets converted to this, this and this. This is the gas, this is the gas. So these two cannot be residue. What is the residue? Residue is going to be silver, which is going to be settled in the container at the end. So technically, I'm supposed to calculate what mass of silver is formed here. What mass of silver is formed? See guys, first of all, how many moles of silver carbonate we have? How many moles of silver carbonate we have? Mass of silver carbonate 2.76 grams divided by molar mass of silver carbonate. The value is 0.01. So we are starting with 0.01 moles of silver carbonate. Now we use the stoichiometry. Stoichiometry is telling you 1 mole silver carbonate. 1 mole silver carbonate, when it undergoes heating, strongly heating, it gives 2 moles of silver. Therefore, when 0.01 moles of silver carbonate are strongly heated, you will get 0.02 moles of silver, right? You'll get 0.02 moles of silver. But as per the question, are we supposed to calculate moles of silver or mass of silver? I'm supposed to calculate mass of silver. Mass of silver means moles of silver multiplied by molar mass of silver. Molar mass of silver is, I think, 108. Is it 108? Yes, I think so. So it is 2.16 grams. So 2.16 grams of silver is formed at the end. That means 2.76 grams of silver is left in the form of a residue, right? So this is the question. So remember this guys, huh? Ag2CO3, when it's strongly heated, it gives silver, which is the residue basically. Perfect. So remember this sort of a question as well. Now, this is a common and basic question. I believe all of you can easily solve this. Tell me its answer. The question has been asked in 2009. H2 gas, you are making it to react with O2 gas, right? Exploded amount of water produced in this particular reaction. Amount of water produced in this particular reaction. Mass of water produced. So, initially, how many moles of H2 do we have? We have 10 grams of H2. That means we have got 5 moles of H2. 64 grams of oxygen means 64 divided by its molar mass is 32. So, 2 moles of O2. In the beginning, this is 0. Is the reaction balanced? The reaction is not balanced. So, balance the reaction. This has to be 2 times. This has to be 2 times. Now, the reaction is balanced. Now, check which one is limiting reagent. 5 by 2, 2 by 1. 5 by 2 is 2.5, 2 by 1 is 2. So this one is limiting. If this one is limiting, completely consumed, nothing left. All the product formation is decided by O2. Now tell me, 1 mole O2 gives 2 moles water. So 2 moles O2 gives 4 moles water. So at the end, I would say 4 moles of water will be formed, right? Option 2. Do you understand all this? All easy, right? And guys, these are all asked questions. I hope you're understanding all this stuff. All right, this question is asked in your JEE 2019. Look at the question. 25 grams of an unknown hydrocarbon. So you have got an unknown hydrocarbon. Let that be CXHY. Upon burning, produces what? It is going to produce carbon dioxide and water. So how many grams? 25 grams of hydrocarbon upon burning produces 88 grams of carbon dioxide and 9 grams of water. 9 grams of water. The unknown hydrocarbon contains. Understand properly, guys. First of all, if you look carefully, if you talk about carbon dioxide, what is the molar mass of carbon dioxide? 44 grams. 44 grams. So can I say 44 grams of carbon dioxide here? 44 grams of carbon dioxide. This is the general information. 44 grams of carbon dioxide contains how many grams of carbon? It contains 12 grams of carbon. Therefore, 1 gram of carbon dioxide contains how many grams of carbon? 12 by 44 grams of carbon. Therefore, 88 grams of carbon dioxide. 88 grams of carbon dioxide contains how many grams of carbon? 12 by 44 multiplied by 88. The value comes out to be 24 grams of carbon. So I got to know in 88 grams of carbon dioxide, there is 24 grams of carbon. And all those 24 grams of carbon has come from where? It has come from here. So basically in 25 grams of hydrocarbon, there must be 24 grams of carbon present. That's why all these 24 grams are finally reaching into carbon dioxide. So if the entire mass is 25, this is 24. So mass of hydrogen has to be 1 gram. So 24 grams of carbon, 1 gram of hydrogen. Did you understand? Did you understand, people? Is it clear? Quick, everybody. Did you understand this? Let me know once in the chats quickly, everybody. It's a simple and basic question now. It's a simple and basic question now. Quick. Everybody in the chats. I would want you guys to light up the chats now. And guys, these are all the asked questions. Do you see the level of the questions? These are very simple, right? If you have watched the marathons, right, you should be in a position to solve all of them. And easily you should be able to solve them if you have watched the marathon properly. Okay? Perfect. Let's move on. This is one more question. This was asked in JEE Mains 2019, and you should be again in a position to solve this question as well, if you look at the question properly. My dear students, you are given with a reaction. The reaction is M2CO3 plus 2 times HCl. It gives 2 times MCl plus H2O plus carbon dioxide. This is the reaction that's given to me. Someone is typing OS Sir Chemistry. OS is a brother, is a younger brother. Yes. Are you his student? Amazing, he's a wonderful teacher. Look here. As far as this particular reaction is concerned, M2CO3 with HCl gives MCl plus water plus carbon dioxide. This is something which is given to me as per the question. Now, my dear students, as far as this particular question is concerned, if you think properly, 1 gram of metal carbonate we have taken. 1 gram of metal carbonate we have taken, right? Now, my dear students, 1 gram of metal carbonate, when it reacts with HCl, what does it form? It forms 0.01188 moles of carbon dioxide. This is something which is given to me. This is something which is given to me as per the question. When 1 gram of this carbonate reacts with HCl, it leads to the formation of these many moles of carbon dioxide. Okay? It leads to the formation of these many moles of carbon dioxide. What are we supposed to calculate? We are supposed to calculate molar mass of this M2CO3. Guys, it's a simple basic question, provided just use your brain a bit. That's it. Stoichiometric coefficient here is 1. Here the stoichiometric coefficient is 1. Can I say 1 mole carbon dioxide as per stoichiometry? 1 mole carbon dioxide is formed from 1 mole of M2CO3? Yes. In order to produce 1 mole carbon dioxide, 1 mole of this carbonate is required. Correct? Now, for 1 mole of carbon dioxide, 1 mole of carbonate is required. Therefore, for 0.01188 moles of carbon dioxide, how many moles of carbonate are required? 0.01188 moles of M2CO3 are required, right? So, if you think logically, how many moles of M2CO3 I got? How many moles of M2CO3 I got? These are the moles of M2CO3 which we have in the beginning, basically. These are the moles of M2CO3 which we have in the beginning. Now, moles of M2CO3 means mass of M2CO3, that's 1 gram divided by molar mass of M2CO3, that is 0.01188. So from this particular equation, you can calculate molar mass, which comes out to be 1 divided by 0.01188. Solve this term, and this is going to give you the molar mass of M2CO3, which I was supposed to calculate. Yeah? Perfect, guys? Right? It's okay, guys. You can make 86. Doesn't make a lot of difference. Did you understand how do we deal with this question? 1 mole of carbon dioxide is produced from 1 mole of metal carbonate. So these many moles of carbon dioxide will be produced from these many moles of metal carbonate. So basically, in the beginning, we should have these many moles of metal carbonate. So number of moles of metal carbonate which we had in the beginning, these many. Number of moles of metal carbonate is equal to mass of metal carbonate divided by molar mass is equal to this. So from here, you can calculate molar mass. Yeah? It's again done and dusted. All right. This is going to be, I believe, the last question of the session. And there will be 10 homework questions. There will be 10 homework questions which will be in the slides, and you are going to solve them. The slides you are going to get on the Telegram channel, which is Wassim Bhat Chemistry Official. This is the name of the Telegram channel. This is the name of the Telegram channel on which you'll be getting the PDF of this session. And I'm keeping some 10 questions as the homework, which you guys are going to solve on your own. Right? Perfect? Yeah. Right after the session, I'll be uploading it. Right after the session, I'll be uploading the PDF in the Telegram. Okay? So those 10 questions you are going to solve on your own. 10 to 15 questions I'll keep. Or maybe I'll keep some 20 questions. I'll see that after the session. Okay? And guys, on Wednesday, what do we have? On Wednesday, we have got chemical bonding. All right, look at this particular question. How many moles of magnesium phosphate will contain 0.25 moles of oxygen atoms? Guys, understand properly. Can I say, if you look at this particular compound, can I say 8 moles of O? 8 moles of O are present in 1 mole of magnesium phosphate. 8 moles of O are present in 1 mole of magnesium phosphate. Therefore, 1 mole of O will be present in 1/8 moles of magnesium phosphate. Right? 1 mole of O will be present in these many moles of magnesium phosphate. Therefore, I must say 0.25 moles of O will be present in 1/8 multiplied by 0.25, which comes out to be 1 divided by 32 moles of magnesium phosphate. Okay? So these are the moles of magnesium phosphate which will be containing these many moles of O, right? And when you solve this, I think the answer is going to be 3.125 into 10 raised power minus 2. Right, people? Okay? I think this much is enough. And I hope you exactly got to know what kind of questions are asked from the chapter mole concept, from the PYQs. You saw what are the NCERT in-text questions from the mole. You saw what are the NCERT exercise questions. All of them we have solved. Okay. There are some like 10 to 20 extra questions which are not from NCERT. NCERT questions we have already solved, right? PYQs we have already solved. There are some extra questions which I'm keeping here, right? In the PDF of this particular session, I would want you guys to give them a try. Perfect. And do let me know in the comment section of this particular video. Did you enjoy this session? Do you want more such kind of the sessions? Do let me all of that in the comment section of this particular video, not in the chats. Okay, in the comment section. Chalo. Take care. God bless you all and